Hello, Chair.
Okay, ready to start?
Yes.
Okay, let's carry on. Okay, let's just go over. Let's just go over in case you are a bit blur.
All the essay, Chair.
Yeah, no, just number 2, then we will call it a day.
Okay.
Just review in case you are a bit blur, what is happening. Very popular lah, magnetic field. That's why I have to review with you. Okay, where is it? This one. Remember that? This one we have done before. Just review with you in case you are still blur. The field, in this type of question, you need to remember this one, right hand. The thumb represent the current. The direction of the field is the fingers show the direction, right? It's always circle. So like in this case, right, you need to imagine there's a circle there. And then in this case, since it's going in, it must be clockwise, right? Clockwise. So the field at this point there is a tangent. So it means at O, there's a bigger circle, it will be a tangent coming down. Right? Same with one. This is a big circle. So if it's coming out, it must be anti-clockwise. So the field is a tangent to the curve there. So it means that you must imagine that the point O is a big circle there. It's going towards red one. Right? So for this field, the vertical one to cancel this must be going up. Okay. So essentially, you have to look at this point first. This point, right? Whether it's going to the right or to the left, and then you choose. So it can only be A or C only, and then you just go and choose. Okay. So if you understand that, let's go over. Okay. State Ampere's law. You must do that. Memory work. Okay. Then after that, you are just applying Ampere's law, that's all. Where you think of a wire carry a current, a straight wire carry a current, and then around the wire is a magnetic field or radius R is circular, right? If it's a conductor, circular loop or radius R, that's your field. Then you apply Ampere's law. Right? B is circle, so the circle is 2 pi R. Then y is enclosed is mu naught times I, and then get your answer. Okay. All right, then by this one, right? They've given you the current value. So essentially, this is a right angle triangle, right? It's a square. So these two sides are the same. Yeah, we call that on A if you like. Right? So you know your math straight away, you can get the answer. If not, calculate out. Right? All A. Right? A square plus A square is your 10 square. Then square root that, you get your value of A. Then after that, you can look at your calculator B1 and B3. B1 is due to this one. Right? This one is clockwise. That's why you get it here. tangent. And B3 is also B3 is anti-clockwise. That's why you get a tangent here. B1 and B3 add together. We call that magnitude X. Okay, so we are just using this formula, mu naught I 2 pi R. So there's your mu naught, 2 pi, there's your 2 pi, there's your, right? R is your A value, this value. And then your I1 and I3, right? Add them up, get your answer. Then B2, due to I2, remember I2, it is anti-clockwise. Right? Remember a big circle, so this one will be a tangent, that's due to B2. B2 is I due to I2. And B4 is due to I4, this one. Right? This one is going in, so it's clockwise. Clockwise, so at this part, it will be tangent there. So B2 and B4 are the same direction. Add them up, call that Y. Right? So it's the same. Right? Using this formula, mu naught I, this is your I. Right? I2, this is your I4. And 2 pi taken out. A, this is your A. A is common factor, take out. Right? Change it to meter. And calculate out. Right? Remember, it's a square. This is a square. Sorry, a right angle triangle. Right? Right? If not, you can redraw. Draw this side. That's your Y. This is your Y. And then this is your X. That's your X. And then this is a right angle triangle. Right? Or you can resolve if you prefer, whatever. Doesn't matter. Anywhere. Whatever you learned in your previous set. Right? Let's remove the confusing. Right? There's your angle theta. That's your X. That's your Y. Right? This is your X. Here. That's your Y. Here. And then there's your resultant. Right? Draw a diagram to show your angle. Then no need to explain. But that's your angle. Then go and find your R. This is your R. Okay, I take the common factor out. 10 to the power minus 4 out. So it's 1.36 square, 1.95 square. Got that? Right? Then you can use whatever you want to calculate, X and Y or R. Right? Here's your R. Let me just rewrite that R in there. How come I didn't put it inside there? Okay. So that's your R. Okay, that's your R. Calculate your R. Right? And then you can use whichever value you want. Right? In this case, I use tangent, X over Y. Right? X value we have calculated. Right? That's your Y value. I think you booked something wrong here. Instead of using 4 pi, I think you use 2 pi. Something wrong in your book. That's why your answer is wrong. The answer in the book is different from mine. Right? As long as you know how to do, that's good enough. 30, so theta is 35 degrees. Yeah, I'm very careless. Okay, any comment? Anything not clear?
No, no, okay, sir.
Okay, so we have done that. Calculate the magnetic direction of the resultant field. We have done that, 1 and 2, we have done that. Then it says state the motion of all the wires if the current I1, I2, I3, and I4 are of the same magnitude and direction. Right? If they are same magnitude and direction, give reason for your answer. Okay, same magnitude and direction. So in this case, if it's like current, what will happen to like current? Yeah, what happened to like current?
Like current.
Like current, that means they flow in the same direction. Two parallel conductor. Would they repel or attract?
Repel.
Like current, like charge will repel, like current will attract, opposite.
So current will attract. Okay.
Okay, so between I1 and I2, there will be attraction. Between I1 and I4, there will be attraction. Okay, so these two are the same, right? Magnitude the same. So the resultant will be in the direction of I1, I3. So between I1 and I3, there is also be the attraction. So the resultant is along this line. Right? You can try for all the other current the same. Right? So they will move towards each other, right? In the diagonal direction. The wires shall move towards the center C of the square. The forces are attractive. Example, the force on I, wire 1, both to the right and downwards. Right? The force on I1 due to I2 and I3. So due to I2 and I4 are to the right and downwards there. So they have a resultant in a diagonal. So between I1 and I3 is also in the diagonal. Right? That's what I mean. Okay. Okay with that? Anything not clear?
No, okay.
Okay, I think we go to question 1 just to record it down. We still got a little bit of time. Right? A proton move with in the direction perpendicular to the uniform field B, which direct into the page as shown in the diagram. Sketch the path of the proton and the direction of the force which acts on the proton by the uniform magnetic field. So using your Fleming's left-hand rule, okay, the field is going in, first finger, your current is going up, current is going up, right? Current is the flow of the positive charge proton.
Hey, I thought we discussed all this already, Acha.
I just want to record it down for you.
Unless, yeah, because I missed the recording that day, right?
No recording. So I just record it for you.
Yeah, only the structure and essay.
So the first is to apply your Fleming's left-hand rule and get direction of the force. So the force is to the left. So it's
and then it deflect.
Deflect to the left.
Yes.
Right? Then you want
magnetic
to
force equals to centripetal force.
Right? Just put magnetic force as centripetal force. Write down, and then go and get your radius. Right? Take your PE down. 1V, cancel 1V. Take the R to the other side. And put in your value. Right? Get it from your value of constant. That's the mass of proton. That's your speed. Right? Given there. And then your B is given. Right? That's your B. And then E is from your value of constant, and then calculate out. Okay. The proton is replaced by electron, which move with a same velocity in the magnetic field. Explain the difference in path of the electron as compared to that of the proton. So 4 marks, it means that they are looking for a lot of a lot of points, for at least 4 points. Right? So write the equation down. Electron is of negative charge, so it's deflected to the left. The mass is very small. Right? So you may want to say that not very small, but you may want to add a little bit more since there are 4 points there. Right? So you can say that about 1,000 times smaller than mass of proton. Okay, any other point that is related to the question you can write down? Right? Because it's format, the examiner will look for quality. Right? How you reason it out, that is the equation. And then negative charge there, deflected, and the mass, right? 1,000, about 1,000 times smaller than the mass of proton. So the radius is very small. And two parallel wires X and Y are separated by a distance. Right? That's the distance between the wire, shown in the diagram. X carry a current of, that's for X, that's for Y. Right? This is going in, this is coming out. And then O is 0.03 meter. Right? Sketch, this is memory work. Right? If without, you can roughly guess how the graph will look like. If it's without, this one is going to be going in, so it's going to be clockwise, circle, clockwise, concentric circle. This one for Y will be anti-clockwise, circle. Right? So clockwise and anti-clockwise, this is X clockwise, Y is anti-clockwise. So in the middle there, they add up. Right? For this part, they oppose each other, so it becomes weaker, Right? The two are not parallel to each other, so we don't expect them to reinforce. We won't expect them to be circular anymore. So that's how they look like. Right? Stronger in the middle there, weaker at the side there. Anyway, it's memory work. Determine the magnitude and direction of the resultant field at O. Right? At this part there. Right? Remember this formula? Remember that direction of the field, right? Is always circular. So due to X, remember X is going in. So the field is going to be clockwise. So at point O is going to be a tangent upwards there, Bx. Right? Y is coming out. So it's anti-clockwise. So it's a big circle there. Right? That big circle there. Anti-clockwise. So at this part there, it's going down. The two oppose each other. Right? Then you have to choose the direction. Taking outwards as positive. So I take the common factor out. Right? Mu naught I, 2 pi out. That's your mu naught. That's your 2 pi. Then I left with I and R. I, right? This one is X is 15. Right? That's your distance. That's your distance. Minus, right? Because of By is opposite direction, 18. And then the distance is 0.1 plus that one. That's why I get this one. And calculate using your calculator. Okay. So it's positive, means it's going to be outwards. Okay, so we have more or less completed. Anything else you want to ask? If not, we call it a day. Make sure you start doing your work. If not, no shortcut.
Yes, teacher. Sorry for that.
Ask.
Huh?
Anything else you want to ask?
No, sir.
Okay, if not, have a good day. Continue to work.
Okay, you too, sir. Thank you.
And you will improve. If not, you will not make it if you don't put your effort. You want good results, you have to put in the effort. Okay, have a good day. Then we'll stop here.
Problem is, I don't know whether got time or not, sir. That's all I want.
Got what, 1 more month, right? Do best.
Best. Okay, thank
Okay.
you, sir.
All the
Thank you
best.
so much for teaching. Thank you.